Hi, welcome to Introduction to Programming. This is for the DSK in 2018. You can see March 2018 on these slides because that's when I made the slide. That's when I wanted to start the course. So basically this course idea behind this course is to teach you programming, the different stuff along with it, and we'll have section by section. This video is more along the lines for those who weren't there on Wednesday to catch up, because supposedly there was something to do with classes not happening, extramurals not happening, I do not know. And this is basically a catch-up course, and I'll also be adding a little bit to the end in terms of a homework question asked, or a person wanted a homework question, therefore I'm doing that. So in this video, I'm hoping to just basically give you an introduction to programming, the different data types, so forth, how to do if else, then making a small hello world, and then I'm also thinking of starting the loop, so that's what I did last week because I had enough time. So this presentation is slightly not full. So I'm going to be doing some coding in this as well, just showing you how it works, how to get outputs. I am not showing you how to install Netbeans and JDK. You can figure that out by yourself. I will put some links in the description in order to get the contents. I might actually make a small little thing for setup as well, if you guys want that. So, well, what is programming? Well, you can summarize it as someone creating a problem statement, taking that problem statement, breaking it into little pieces, and then translating that into things that the computer can do to get a desired result. So the instructions are considered computer programs to help the computer to operate smoothly. The language used to program is not understood by an untrained eye. That doesn't really matter. That's actually a bit off, because you can understand it if you use the correct languages, because there are languages made around using English to program things. I mean, you do that every time you use your Google Assistant. If you use a search in Google, that type of thing. You are actually using a dynamic programming to do it. But that's a completely different discussion. So there are different types of decimal systems, or sorry, counting systems. The human decimal system that we're currently using here, as you can see, is not 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, we ran out of numbers. What are we going to do next? That's right. Well, if you actually look how we count 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. So all we do is add 1 to the beginning, and then we keep going. When we get to 999, we add 1 to the beginning and start from 0 again. So the same idea applies to binary. It's 0 and 1. And once you get to 1, you run out of numbers. Whoops, let's push it. Start 1, 0. 1, 1, 1, 0, 0, because you keep pushing the number further forward. So the reason why I want to do binary, or I'm just showing you binary, is to say 0 is the same thing as false or no power. 1 means there's power and it's true. That's all you have to remember. You can actually do a ton of complex system using binary in terms of networking and stuff, but that's not covered in this course. It's just an interest factor. Now, if you want to do hexadecimal, hexadecimal is 6 and 10. So it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So once you get to F, you go 1, 0, 1, 1, up to you get 1 F, then it's 2, and so forth. Now, there are primitive data types in Java. These are usually applied to most languages. Java is a language that you have to define the type of variables you're using. There is a strict variable typing. Now, what are primitive data types? These are data types that can be interpreted by the compiler and be used directly on the CPU. There is no classing, no definitions required, and so forth, like you have with objects. We'll get there in a moment. Now, as you can see, there's Boolean, which is just 1 bit, which is 0, 1, true or false. There's byte, char, short, int, long, float, double. Now, if you look at this, you can see that a character is A, or this character code here is the same thing as A, which is just 00001. 0000 is A, 0001 is B. Because we just basically started at 0, and then we just added 1 extra for every character. Now, you can see that character is denoted by using a single quote. And what do you think a string is? So something like a name, saying, I don't know, my name is Marco. Well, it's a collection of characters. So string is just multiple characters put together, and we use double quotes for that. Okay. This table here you don't have to memorize, but you will kind of memorize it once you work with it. So an int is an integer, so it's a whole number, basically. Anything that doesn't have dots. A long is a very complex one. Basically, if the integer has more than 32 bits in it, which means more than 32 positions, it's a very high number. You very rarely will be using longs. Float is if we need to have commas. You'd rather be using doubles because doubles are still accurate with those comma trailing numbers. It's just if you're dealing with money, don't use a float, use double. That's a rule of thumb. You don't need to really understand yet. Once you actually deal with it, it matters. Now, conditional programming, if else. The code is on the left, how this actually works, and the condition on the right-hand side. Now, don't worry that you don't understand it yet, so you still have to use it a bit in order to understand what you're doing. Yeah. So first thing you do is you declare the variable type, which is int. Then you give it a name, and then you assign a value. You don't have to assign a value. In this case, we are. So if you look at this condition, we are doing if the test, which is 5, that's what it stands for, is less than 10, then we'll do whatever is in here. Otherwise, if the test fails, we'll do whatever is in the else. Now, whatever we do in that if, all the stuff that's executed in here will happen, if that is true. If it is false, everything in here will be executed. So this will be completely ignored if this is true. And if this isn't true, then everything here will be done, and this will be completely ignored. But everything afterwards will still be executed as normal. So if we see here, we have a starting point, we have a condition, which is test less than 10, or test more than 10, depending how we do this. And we set up our if else. And if the condition is true, we'll do that, and that will go to the end. Or else we're going to do the else, and we'll all get to the same ending point. That's start, that's end. That's just a diagram to do it. There are so many diagrams. You can use whatever diagram you feel like. I like this form because of the way it's simple. There are a lot more complex diagrams. A diagram is just basically something that we can map something, so we can show logic behind it or how the system is built. There are tons of diagrams. You can Google some. You might like some, you might hate some. This here is a very simple flow graph diagram. Now, I was going to show you IntelliJ and Netbeans, but the DSK is only using Netbeans version 7. I'm a bit iffy with that. Please use Netbeans 8 that you could download yourself. The DSK, you can then use that. IntelliJ you can also use. I would just not recommend it for you guys since it's more for advanced people, just in terms of IntelliJ is more forward-thinking and is not made for new beginners. So there's not as much templating and stuff like that. It's a bit more difficult. So we'll be using Netbeans in our case for everything. Now, let's start a program. Netbeans 8.2. I think there's a newer version right now, but we'll try that out later. Up to you. So the first thing we're going to do, so I'm just going to close everything, is we can start a new project, which is you can either use this button, or you can do File, New Project. You pick a Java and a Java application. Next. Now you can pick a name, whatever you want. The convention is to have the first letter capitalized. Always, no spaces are allowed. You cannot start with a character, a number at the beginning, but you can have as many numbers as you want in here. Okay, so I'm going to call this Hello World. Oh, sorry, we already have Hello World 2 because I need to have a different name. This is the project folder already existing where everything is stored, and then we click Finish. Now we'll create our new project. Oh, and if you want this theme, this is the themes for coloring. Yours is going to probably be white to begin with. Click Tools, Options, Fonts and Colors, and pick Norway Today. And it'll be dark. Or else your current one is this. Netbeans 5.5. Norway Today is the one I prefer. Okay, so if you look at your files here on the left, you'll have your Hello World 2. You can ignore these other projects, we're not using them. You'll have source, Hello World, and Hello World 2. So this is the file we're working in. Everything in your project will be inside the src and the Hello World. You might not have this built-in manifest file. That's due to me using a newer version of Java, Java 9 instead of Java 8, but you can ignore it. It doesn't affect you at all. All you have to care about is the source folder where you're putting your code in. This is called a package, the folder that contains Java files, and we have Hello World 2. So how does our program know where to start? So in terms of if we give this to someone, where do we know where the program begins? Because this all follows a strict logical cycle. So in Java, we always start using in main. We'll always look for public static void main. Notice the folder up here, that package hello world too. It's the same there. So just be careful if you copy paste my code, that package must match your folder name over here. And the hello world 2 needs to match it as well. Now, if you check here, this is our to-do application code, to-do code for our application. So there are certain things you just have to memorize in terms of certain commands and so forth. One of these is system.out.println. Okay, so what is system? System is just our console, out, println. So what this does, if we actually check the code, you can click Control Space to do that in my shortcut. And you can actually check all these commands of what it does. So what does print do? Prints a string. If the argument is null, then the string null is printed. Otherwise, the string's characters are converted into bytes according to the platform's default character encoding. And these bytes are written in exactly the same manner of the print stream write int value. So what we're using is print line. So this also terminates the current line by writing the line separator string. So if you think of a printer keeps going from line by line by line. When does it know when to stop? Well, when we give it the character \n, and then it will work. Okay. So system is capitalized as it's a class, an object. We'll deal with objects later in the course, I think in about 3 or 4 weeks, hopefully. So let's print hello world. That's all we're going to do. So we're going to make a string, which is double quotes, and say hello world, and save that. So click save, or click Control S, that's this button up here to save. And we're going to click run, that's the screen button up here. It's also can be accessed by using F6 as a default. If we click play, then we have this output here. And here we have hello world. Oh no, I spelled hello wrong. Hello world, let's run hello world. There it is, awesome. Just save every time before you click F6. That will do. So that's great. We can now have our hello world. Now the thing is though, we kind of don't want to hard code every single time saying hello world. What if we want a variable that's called hello world and we want to give it different stuff? So we're going to be like string welcome message. All right, so we're going to make a string. And what was a string? String was a collection of characters, which the character is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And we're called it hello world. One had the same spelling mistake twice. So what does the semicolon do at the end of the statement? Well, it just means that our statement is complete, and please look at the next statement. So if we didn't have the semicolon, it would execute all of this like that. So it would think this is all one giant long statement. So we have to separate our statements like that. Please use tabs or for spaces. I prefer using tabs. You can click Shift Tab to do this. Indentation, that curly bracer here means contains, as in everything that is in here belongs to that. Everything in here belongs to that. So this all belongs to that. Always use a tab space or at least one character space to this one. And always put this one in the next line. The last one here has to be over here. You can also have it so that this starts on the same line. You know, it's a straight line. Why do we do this? Well, sometimes we have a lot of brackets put together and then we go really long. Well, what if there was a couple of hundred of these? Oops, sorry. Control. What if we do a couple of hundred of these? Well, where does that all belong to? Well, it belongs to over there because we can directly check going that way up to there. Okay, we're just going to do that. Second. Hello world. The shortcut for that is Control down. Control Shift down. Sorry, Control Shift down. You don't need to memorize shortcuts. You can type them out yourself if you want. Especially recommend you type out everything yourself to begin with. So we want to actually print this welcome message instead. Currently it's gray as it isn't used. We're using an IDE. What this IDE does, it kind of just helps us to code by doing basic stuff for us, like coloring out our stuff, coloring it out really nicely. It's gray because we haven't used it. Strings are all yellow here. You'll have different colors if you're using a different theme, and so forth. So we're just going to put welcome message there. So you can see it's now white because we use it. Plus, selecting and clicking on this one will highlight all our welcome messages. So let's click save it, Control S, that button up there, and click play. Hello world, still printed. Just printed that message. Okay, so that's great. we have hello world. So we have our welcome message. Now, what if we want to tell the next coder, hey, why are we doing this? Or what are we doing in our code? Well, a comment is just double backslash. We can say we are sending or writing message to the user, informing them that they are welcome. And we're going to save that. That's awesome, isn't it? But the compiler, this doesn't matter. Comments don't really matter. The compiler will ignore it, so the stuff that we actually run will ignore it. So don't worry about uploading your code very much. It's literally just source code, which is the stuff before it's compiled, which is this source folder here. Hello world. Our build, it will be totally ignored. Over here, this hello world 2 class will completely ignore it on build. That's what this run does. It builds and executes it. So that's a bit useless, kind of. What we do is have a message. Well, let's make it so that we check if a person, let's call him Harry, and get his age. I don't know. Let's say he's 12 currently, or 13. I don't know. Let's go to 13. And we want to check if Harry is allowed to drive yet. So we're going to check if he's always allowed to get a driver's license. So if he's 18 yet. So if Harry, these brackets means it's going to be passed in there as a method, or to evaluate, it's greater than 17, because that does not include 17, because it's greater than, or else we can use greater than or equals to 18. Then we can say system, capitalize the S, system.out.println, Harry can get a license. I have to put that semicolon. Otherwise, using else, Harry is not allowed to drive yet, or allowed to get drivers yet. And we can save that. Right. As you can see here, the evaluation is inside these normal brackets. And we have curly bracers that contain everything in here. Now, one rule is that you can remember as well for shorthand or short ones. Oh, sorry. Control-Shift-C to comment out the lines, to line comments. We can have no curly braces as long as we only have one statement. So only the next statement will be evaluated. If you want an else, we need those curly bracers so that it knows when the end of our statements are. Actually, I think we can do it without it as well. Well, it's not good practice. So best practice, have those curly bracers here. Remember, that has to be closing one for each opening one, closing, opening, and inside this else we can do that. So this will evaluate if Harry is greater than 80 or equal to 18. And if he is, Harry can get a driver's license, or else he's a bit young to get it yet. We'll have to wait a couple of years. So let's click play. Hello world! That's our message from up here on line 19. Harry is not allowed to get a driver's yet. Very sad. So let's say Harry got a bit older. Now he's 19, really wants to drive. Save that, and we click run. Harry can get a license. That's amazing. Harry's getting old. So this is really awesome in terms of we can evaluate anything we want. We can check with integers, we can check with floats, doubles, whatever. Int is just a whole number. So one thing I want to mention quickly is camel casing. If it's a normal primitive data type, so in character in that entire list that we had over here, one of these, always write it small, Harry. If it is an actual object, like system, it's always capitalized, or string, capitalized. If it's an instance of it, small, welcome message. So small for your variables, use a small letter. For the names of things and classes, use a capital letter. Okay. Now, the next section here I want to deal with is taking a user input. So this is system.out, so output. Well, now we want to take some input, right? So there's a certain class called scanner, and we're going to call the variable input, and we're going to make a new instance of it, and we're going to call it scanner, and it's going to take input from the system. Standard input stream, which is from the console that we're running. And we get semicolon at the end and save. As you can see here, there's a red text. If there's red, always hover over it. Your IDE will tell you it cannot find the symbol. We can right-click and we can fix imports here if you want to, or we can refactor it. The best case shortcut always is to not use your mouse. You use on the line, you click Alt and Enter, and you can add the import. Yeah. The one that we want to use is java.util. Ignore the jdk or .com dot. That's because of they are different packages for it. Always use the java.util. Okay, now we can click that. Now we won't have an error anymore, because if you see up here, we're now importing that class, so it knows where we're using a scanner, because it can't use it if we don't give it to it. So now we have an input. Currently it's great because we're not using it. If you hover over it, it says variable input not used. So we're going to ask the user. Sort is just a shortcut, and you just hit tab, write it out. How old is Harry? And the next thing we're going to do is we're going to use that input. We're going to click dot, because that gets all the methods from that object. And we're going to check what we can get. So that's going to use has next. Let's check what that does. Returns true if the scanner has another token as an input. But that doesn't seem right. That's not a bit useless. What about next? What does next do? Finds and returns the next complete token from the scanner. A complete token is preceded and followed by input that matches the delimiter pattern. This method may block while waiting for input to scan, even if previous implication return true. Well, not sure what block means. I'll show you later what that means. But it takes the next token from this input scanner. So we're going to do that next. Now it's a bit useless because we're just taking the input and we're not saving it to anything. There's no variable. So we're going to make it so string, this is the age. Notice the Pascal casing, first letter small, each word has a capital letter. And it's all written as one. So I wrote string incorrectly, sorry about that. String, input.next. So this is the age, and all we're going to do is we're going to print out that this is the age. This is, there's no autocomplete. Sorry, I'm used to that. I haven't set it up on Netbeans. This is the age, and then we're going to have Harry Potter, this check here. And we're going to, just for now, we're going to comment it out, Control-Shift-C. The other option is is Shift-Alt-A. Oh, it doesn't work, sorry. That's an IntelliJ. Control-Shift-C, save. And then we're just going to run this. So we'll save C. We're going to run this. How old is Harry? Well, this is what it means by blocked. The program is not continuing executing system.out. It's still waiting for us to finish this. So the program is still running here. Okay? To close the program, click the X button. Yes. Always check if there's a program still running there, because you cannot. This button will be grayed out. As you can see, it's gray. You can't execute it. You first have to close it over here. So how old is Harry? Well, Harry is 2000. So it prints out 2000. Amazing, isn't it? Now, what if I say, how old is Harry? I say that. Well, that doesn't really work. We only want an integer, don't we? So we're going to say int. Now, there's a slight problem, and it says string cannot be converted to int. That's because if you check this, let's control space again. Our next is over here. It will return a string next. Okay. So what we need to do is get an integer. So let's see if we can find that. Oh wait, look over there. That's the next int. Public int next int. It scans the next token of the input as an int. That's what we want, don't we? And that can go away. Save it. And let's check how Harry is that number. Oh, that works amazingly. Do note that I haven't told you how to do checks like this. You're going to have an exception if it's the wrong type. We're going to handle exceptions a bit later in this course. Maybe making checks and stuff for it, if it is an integer or not, and then I'll move on to actually making try catches, exception handling, so you can handle any exception known to man, because that's really a program. We all like to break things, so we have to be able to handle if something breaks. So this prints it out. We know that it gets this data, so we don't need the line anymore. We can get the input, and this is going to be Harry's age, isn't it? So we don't need to define Harry anymore. We don't want to overwrite Harry or Harry, two of them. Rather than changing Harry, we're just replacing him with himself. They'll be clones. Anyways, we're going to check Harry, and if Harry's greater than 18, it will print out Harry can get a license, or else it'll print out Harry's not allowed to get a driver's yet. So how old is Harry? Harry is 12. Oh, Harry's not allowed to get a driver's yet. That's very sad. Let's run that again. How old is Harry? Harry's 21. Oh, you can get a license. That's amazing. So you can use this variable as long as it's been defined previously as many times as you want. Good practice is every single object that you declare at the top. Declare up here. All this type of thing is Harry. So good practice would be to write in Harry here. And then you're not overwriting Harry, you're just going to say Harry is equal to that. And how is Harry? Okay. We can use normal print for this. How old is Harry? And we can put space at the end of that, just so that looks nicer. Because hello world, how old is Harry? We're putting it on the right side, on the same line. 21. Harry can get a license. Amazing. Okay. So, but that's a bit annoying because what if this only runs once and then I have to start again? Whoops, wrote apostrophe. And it only runs once and it's over. Well, that's a bit useless. Keep having to hit the play button the entire time. Keep having to rerun that program. What if I want to run it forever? Well, one thing we can do, I'm just going to comment all this out. I'm going to ignore it for now. But you can see the scanner input is being done. We're going to say an integer of, let's say my number is equal to, let's say the user can define that. It's going to be an integer. Sorry, typing badly today. Input hasn't been defined because it got defined up here. Save that. And then we're going to do this. We're going to say, well, while my number is bigger than 0, we're going to print out that number each and every single time. We're just going to keep printing that number. So we're going to print my number every single time. And at the end of our while, well, let's run it without doing that at the end. Well, currently what's going to happen is it's going to keep printing out my number, right? So what's my number? We haven't printed out the system message to the person knows about it. We're going to just put in a number, 2. So we'll keep printing out 2 forever because it will evaluate if this is true. And as long as this is true, it will keep doing it. So at the end of this, it's going to go back to the top and going to go, hey, my number. So if you actually look at it, it goes from this line back to the top. Yep. While true. And as the number never changes, it's always 2, it'll run forever. And this is where we need to click that X button. Because we have that is your first infinite loop. That's like yes. Just to stop it from running. So this would be a very bad way of doing it. It got stopped. The program crashed. We forced it to crash. So the best thing we can do is we can just do my number minus. It's equal to number minus 1. And save. So now if I put in 2, let's run that. If I put in 2, it'll run 2 and then it'll run 1, and it hits 0 at the end of this. Well, then that's no longer true. 0 is not greater than 0, so it won't run anymore. So how does that help us? Well, we can make infinite loops until something becomes true. Do you want to exit? That's what we're going to ask the user, right? So then if we want to make the user exit, then that number is no longer useful since we're not looping through multiple options of making it count. So while this my number is not equal to something like, let's make this a Boolean and say that the person's input is this, while quit is equal to false. We don't want to quit. And we can check here, as long as quit is not equal to false, always true as long as quit is not equal to false. Sorry. Equal to, as long as quit is equal to false, then we want quit. So do you want to quit? And then we're going to make it so that quit is the next Boolean is equal to input dot next Boolean dot next Boolean. Let's see what happens. Play. Do you want to exit? No. False. Do you want to exit? False. Want to exit? Sure. Ooh, we quit. Amazing. Now if we check on this loop, we got out the loop. And will this print? Well, if we go here, do you want to exit? No. False. Do you want to exit? False. 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 True. Oh, then we get to the message. So it's whatever happens of this while loop, as long as it's not inside here, will happen the moment this evaluates the opposite. So while equal to false, The other way we can write this is we can use that. This exclamation mark, all it does is flip the operand around. So instead of evaluating if it's true, it's going to evaluate whether it's false. That's all it does. Okay, so it checks whether while quit is false, then we'll keep doing that. All it does is a flip. Well, the moment its value is not true, then it will do it. So if its value is 0.5 or something, it's still not true, therefore it will be false. Therefore it will quit. Okay, so we kind of also want to actually check that the user says yes, no, maybe, goodbye, something like that. So as long as that's no, we're not going to quit. But strings is not a primitive data type, so we can't use the equal signs, at least not in Java. So we can check is contains content equals or content equals or equals ignore case. What does equals do? It compares the string to the specified object, because the string is an object and not a primitive data type. So we're going to ignore the case as well. By that, we don't check if it's a big letter or a small letter, capitalized or not. And we're going to check as long as it equals, while this does not equal, as long as this equals no, we're going to do it. You want to exit as long as you say no, you're fine. So yes or no. The moment is it isn't. We're going to check quit equal to input.next. Save that, and we got out the loop at the end there. So do you want to quit? No. You want to quit? No. Yes. We got out the loop. Amazing. So the input is worth the next one. We can also make it, instead of doing this, if this is quit, we can do yes, no. We can check if quit. Sorry, it has to be below, because quit has to be the next input. Actually, we should actually make a new string, user input is equal to input.next if user input dot equals, ignore the case in our case, yes, or this is an or. It's two straight lines. It's the key above your enter key underneath your backspace. The other one is and, which is if both are true. What we're doing is currently or user input dot equals ignore case, yes, then quit is equal to quit. Sorry, spelling mistake there. And quit is equal to quit. I'm going to put a semicolon at the end there. Otherwise, we're not going to do anything because it evaluates false. Anyways, right? Because then it's still whatever the previous input was, which was no. Okay. So let's click run. Oh, sorry, apologies. Quit is equal to quit, so that's to be no, not that. Sorry, no, false operandus. You want to exit? No. Bad input. Some numbers. Well, at no point do we say yes. Yes, we got out the loop. So we can actually change it so that you want to exit becomes, sorry, you put the wrong input. You want to exit instead now. You want to try again. Sorry, the input is wrong. And you want to exit. Yes or no. So as long as that happens, we can do that. And we can make this string put input.next there. So we can change our logic a little bit. Let's move that one up to first checking. And this can be our string.quit. And we're going to move this user input to above, because we're going to check the user's input right at the beginning. And we're going to ask the user to say, do you want to quit right at the beginning? Which is, we already have that. We're going to ask the user, do you want to exit? Yes or no? Check here, the user input's defined. And we're going to ask the user for the input. User input equals input next. Apologies, this input.next shouldn't have happened yet. So we're going to check the user's input. We're going to ask the user for his input. If the user wants to exit, we're going to quit. If we can't understand that, because it's not a yes or yes, or if it's the user input dot equals ignore case no or whatever. We don't even care because we're just going to say that the input is invalid. I'm going to put that over there. Sorry, I'm getting a bit more complex right now as I'm thinking the logic through. I should have done this before actually making the video. We can check here. If the user says yes, sorry, the input is wrong, will always happen. If we check this, if he says anything besides yes, sorry, the input is wrong, that will happen, which is a bit useless. This should only happen if the answer is not no, ignore case, no, or the user input not equals ignore case, yes, or I really don't want to keep typing this, so I'm going to cheat this slightly. I'm typing that wrong again. I'm going to copy this. Equals the single letter, or equals the single letter. Sorry, the input is wrong because we only want yes or no. And then right at the beginning it says, do you want to exit again? Yes or no? Amazing, isn't it? So we're going to ask the user if they want to quit. If it's not the correct thing. So we're going to put else function here. And we're going to move that up there. Because if the user didn't get a proper info, we're going to say that. If they said yes, then we're going to allow that. So this here, if it's equal to quit, we'll go into here. This is all just logic. I know it's a bit complex at the beginning. That's all very complex. We're going to step through it right now in a moment. So while right at the beginning, we're going to ask the user if he wants to quit. Sorry. Do you want to exit? That's what we want to do. Yes or no. Then if the user says, well, automatically, it's always going to go through this loop because right at the beginning it's going to say no instead of quit. So therefore it's false or true for this evaluation because we're using this flip operandos. And if the user input equals no, or yes, or no, or yes, then this will happen. So currently this is all wrong because we actually don't want to print this. We only want to print it on the else because all of these are valid inputs. If it's a valid input, why do we tell the person the input is wrong? So all of this has to actually be flipped right at the end here. So if any of these flip, whoops, sorry, if any of these are wrong, or if it's not any of these, then it will be false, which this is checking for. Therefore, it will be true because we're flipping it. So 0, 0, 0, 0, 0 will then be flipped, and we'll check for 0. If it's 0, which means true in this case because we're checking for 0, then this will be printed out. Else, if the user ignores the case and the user input is the quit, so it's one of these options that are allowed, it'll quit if it's yes. Or otherwise, if they say no, then you want to exit, yes or no. And then we got out the loop over here. So we're basically embedded to this. As you can see, why it's so important to use indentation is that this is very difficult to read this very quickly. This is all on the same line. This looks a bit iffy. Because if I look at this line, this if statement, where does it belong to? Well, I don't know. I have to check. This goes over there. Where does that end? That ends over there. Where does this end? That ends over there. That ends over there. That's a bit of that's a bit difficult to see. So please indent using the indentation. I can see instantly, hey, this has to go that one. This is the parent. This has to be true for it to happen. All right, so let's run that. See if I got the logic right. Do you want to exit? No. Do you want to exit? Oh no, we have an infinite loop. Why do we have an infinite loop? Because we don't actually ask the person for their input again. Yeah, this one, sorry, the input is wrong. We don't ask for their input. So we need to input.next. So the user input is equal to input.next. Sorry for that. And you want to exit also needs input.next. User input equal to input.next. There are more efficient ways of doing this. You could actually rewrite this to be a bit more efficient. I'm just doing this with if and if else's. Sorry, no, if and else's. There's no if else, or else this would be more efficient. So do you want to exit? No. You want to exit. Blah, blah, blah. Sorry, the input is wrong. You want to exit? No. You want to exit? Yes. Go off the loop. So as you can see, this logic, if you step through this logic, we can do that. Now, debugging is a very big thing in programming, because we can then check our logic. Because how do you know where in the program you are? What if I want to check at the beginning what the value of something is? So we can actually use the IDE to click on the line number. And let's say all the little breakpoints that we want to break there, we want to break there. And we press this button, which is called Debug Project Control F5. If we click play, we get this very huge thing, get debug menu there. You want to exit there, we have a debugger console here. And you want to exit, we can say no. If we check no, then it will hit this line. This line will be green. It says the program is here. Program counter and breakpoint. So these red things are called breakpoints. And it will tell us right at the beginning, first time we loop through, what the values of everything is. So here's our input, which was the input given. User input is our variable over here. It's a string, and the string's value is no currently. So if we check here, that's the input that we gave. We can actually ignore this. Doesn't matter to us. These are all static variables that are there. That doesn't matter. We don't really care. These are the two things that we made, and they're both currently no. Now, if we want to step to the next part, we use this play button to continue. And because we hit no, the if statement evaluated to not happen, false, which is true because we're using the stub parameters. So the if else happened, then if happened here. If user input yes or no, or yes, sorry, then it will quit, but we didn't. So this one here was evaluated to false. Then before we got to the else statement, and this happened. Do you want to exit, yes or no? It's still no, because we haven't hit this point yet. So let's see if we can do that. Get the user input there. We can click play. The user input still no. Now it's waiting for us to say the output, so we have to click this output here. Do you want to exit? We're going to write that. We're going to write nonsense. We're going to hit enter. Now if we check here, we click the output, to close it again, and we click the play button to get to the next step. And while this happens, as you can see, this is a really long text string that is completely useless. We're going to click play again because that while true never happened again, or that was not quit. So this is not no, yes, no, or yes. Therefore, it is an invalid input. So it got to here. So we have the DKM, LS, DF, KM, LDF. Next time I'll say something that actually makes sense. Sorry, the input is wrong. You want to exit. As you can see here. Yes or no. Now if I click no, we have to click play button again, so it goes to the next statement. It goes back to this while loop. It's still no, because we set it equal to whatever the next input is over here. And we click play, and we got else here. Do you want to exit again? If we check our output here. Sorry, we need to go to the next one, because this hasn't happened yet. Do you want to exit? It's over here. Yes or no? Now we click yes, and we click enter. We click the play button, so it goes to the next step, goes back to the while loop, evaluates it, yes. Now if we click play again, it has now gotten to, sorry, the play button didn't happen yet, so it's evaluating. And then we set it equal to that, which set equal to quit. And then it's back up here, and the program is over. Output here, it's empty, still successful. Amazing. So we can use this loop to make a lot of text checks. We can ask the user for different things, saying hello, goodbye, good day to you, things like that, right? So now let's make something a bit more complex. Let's use some maths. No, we don't like maths. Let's make a very nice Christmas tree. So what I mean by that, let's do something like I want to have it so that the user asks for something. We ask the user for how many lines do they print? How many stars? How many stars? User prompt how many stars? And for every star they want, we'll print 4 stars, or 1 star for each user prompt. So times the user prompt. 1 star for every user prompt. So not user prompt, for user value given. Sorry, I'm saying this really badly. You'll understand in a minute. So if the user, let's say, picks 4, then we will have 1, 2, 3, 4 stars. Then we'll have 3 stars, we'll load 1 less. Then we'll have 2 stars, and we'll have 1 star. Okay, so that's what we're going to do. We're going to remove all of this stuff. We don't need any of this. We're going to do that, and we're just going to ask the user. We don't need that breakpoint anymore. Breakpoint close. There we go. We're going to ask the user, how many stars would you like? And then the user stars, which will be an int. Let's just say it's an integer, just so we know later on. Stars is equal to input.next int. Close that. So we can ask a while, and check it's true. While stars is greater than 0, we're going to print stars. So we're going to print out stars. And then we're going to make stars minus 1. Stars is equal to stars minus 1. Now, I'm going to show a small shorthand. Since we do this so often, programmers decided, hey, why don't we make a shorthand for this? And the shorthand is minus minus. So it'll be stars, which is, I don't know, a number given. It'll be 10, let's say 10, minus minus, which will be 9. So it will set stars equal to stars minus 1. So that's the equivalent. So what we can also do then, if we don't want to do minus 1, we can also do minus equals 5. So now 5 is subtracted, or 200. And we can do this with any symbol, 2090, sorry. We can do it with any symbol, times equals, plus equals, divided equals. That will all work. But we only want to subtract 1 for every loop, so we're going to do minus minus. So let's run this, and it's going to print a star, 10, and we should get 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. 10 stars there, 10 lines. But that's not what we wanted. We wanted to print a line for each one. So let's do int row stars, which is equal to stars. So this is how many stars, which is how many rows actually. And sorry, this is how many rows. And this is how many stars. And for the first one, it's 4 and 4. So row stars is equal to stars. So 4 and 4. And the second one has to be minus 1. So what's the easiest way of doing this? Well, we could make 2 while loops. So row stars is greater than 0. And we're just going to print out the stars in there. Sorry. Used to different shortcuts. So then, system I'll print there. We'll print out the stars. And we need to make the row stars smaller by 1 every time it prints out, and then equal to that. But the problem here is that we'll see in a moment. Let's say we have 5. Is that it'll print out that many stars. That won't really work out, will it now? If we have 5, it has to equal to 5. So row stars is equal to stars. Check here, 5 stars. So it never gets reset. We actually want to do print instead of print line because we don't want to start a new line each and every single time. So while row stars is that, we have that. So how many stars? 5. 1, 2, 3, 4, 5. Okay. This is stars minus minus. There's row stars minus minus minus. Now the problem we've reached is that this hits 0, and then it's 0 every single time we leap through. So at the end of this, we're going to do row stars is equal to stars. Oh, sorry, equal, not minus. Nothing to worry about today. So that when this hits, let's say 5, and it's 4, then row stars is equal to 4. We check here. Let's do 4. That's all on one line, so we have a slight problem that we need an empty line. So at the end of this, we're just going to end the line. How many stars would you like? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. And there's 5 rows. Now we have a star system. So that's the end of the lesson for today. One thing I want you to try out that might be interesting is instead of making it have spaces at the end of this, why don't you make it equal to have dashes at the end of this? So sorry, this will be 3. So it's always going to be the same amount of characters as lines. And instead of having spaces at the end, we're just going to use dashes. So this one here will have to have dashes instead. that's a small little math problem that you can figure out. So let's say we have this here. Let's say we have 10. Then this must have 1 dash, 2 dashes, 3 dashes, 4 dashes, 5 dashes, 6 dashes, 7 dashes, 8 dashes, 9 dashes, up until the end. So we always have dashes where every space should have been. You can use any other symbol you want. You can use pluses and minuses instead of using stars in order to make it so it looks a bit nicer in terms of the star and the minus will be the same size, because we have, let's say we have 5 stars. We want 1 minus at the end there. Let's just write that. Let's just make that print out. At the end here, print out a minus. Check here. That will be then in the same alignment. That looks very nice. So try that out. On Wednesday, I will give you the solution for that. I'm also going to later on, either today or tomorrow, hopefully still, is make a GitHub tutorial that you don't need to learn because the DSK doesn't allow or doesn't have Git installed. But it's kind of used for pretty much any work environment to share code with in order to have different branches and so forth. And it's kind of helpful, especially if you're working together, because then you can share code very easily and everyone can work in different branches and so forth, all the merits for that. I'm making this video anyways for another friend, so hopefully that works out. So I hope you learned something. And on Wednesday, I hope we have some classes. I'm going to give this video to some of you guys and hope you give it to the others. Please do look in the description because I'm going to be posting some videos I'd like you to look at in terms of I want you to look at the first and second video of Michael Fudge. He made a Java playlist and he explains this a lot better than I. Mine is really just going through it very slowly and I don't have the best points for everything. He teaches very well. So if you didn't understand what I did, please go through his videos. He does also a lot more advanced things than I'm doing. And then you can also go through it at your own pace. I don't have the time to make a video for every single lesson. So I hope you guys enjoyed it. I hope you guys learned something. For the setup, I might make another video, but I think Michael Fudge also has a video for setup, so I'd rather use that one. Netbeans does have a problem with the newest JDK, so please get JDK 8 instead of 9. It's just going to avoid some problems later on down the line. So as you can see, I have this weird extra files that's from JDK 9. Okay, hope you enjoyed it, and goodbye.